Hey guys, welcome to Unit 6, Lesson 2. Today we are going to be doing continuity on an interval. And our objective is to determine if a function is continuous. One thing is that, and the other one we're going to be talking about the intermediate value theorem and show the existence of certain values on an interval. So there are two things that we are going to target today. So pause the video and try the warm-up. So I sketched the function on the right and let's answer these questions. It says let f be defined by the function. Which of the following statements are true? Explain your reasoning. Before I even start that, let's simplify this further. So in the numerator, I'll just switch colors and I can factor out the 4 and I'll be left with t plus 3. In the denominator, I can factor it as t minus 5 and t plus 3. What happens to my t plus 3's? They cancel out, means it's a removable discontinuity, right? And that's how I sketch my graph without the calculator. I knew at 3 I will have a hole, right? Because I was able to remove the discontinuity, and at t equals 5, it's a vertical asymptote. So let's answer all those choices. Which of the following statements are true? Explain your reasoning. F has a limit at t equals -3. So let's check. From the left, I'm approaching -3. From the right, also I'm approaching -3. So yes, F has a limit at t equals -3. It's true. F is continuous at t equals 5. It is not continuous. It's false because we have a vertical asymptote there. F has a vertical asymptote at t equals 5. That's true, but this is false, so will be false because we have a hole there. Only at t equals 5 we have a vertical asymptote. And f of -3 exists. No, it does not because it is an empty circle. So that is false. Continuity on an interval. A function is continuous on an interval if and only if. So that's the criteria. If the function f of x is continuous at every point in the interval. Let's investigate this further. So draw the graph of the function. So pause the video and try to sketch the piecewise function. So I graphed the piecewise function, and now the question says on what interval or intervals is the function above continuous, right? So wherever we have a discontinuity, we're going to take that into consideration. So our function is continuous. If I start from the left, you always write it from the left. It's from -∞ to 1, right? And 1 is what included. How do I know? Because it's a filled circle and it's all actually you can write about your continuity right from here. So it's going to be a closed circle and then from 1 to 5, which will be an open circle because at 5 it's open and closed at the same time. And then from 5 to 9, which is also a closed circle. This I can combine and write it as 1, 2. So a function f is continuous on an open interval. You all know what an open interval is, right? Something which will have like this. AB if it is continuous at every number on that interval. So that is what like a graph will look like if it is continuous at every single point. There's no discontinuity, so it is continuous over this interval AB. Our function f is continuous on a closed interval a comma b if it is continuous on an open interval, and let's write this down and then I'll explain. And it's very self-explanatory. Limit as x approaches to a from the right, f of x is equal to f of a, and limit as x approaches b from the left, f of x equals f of b. So if this is same, then it is continuous, right? So what does the closed interval means? Meaning, let's write that down, endpoints are included, right? That's what the closed interval means. Okay, so let's try this. Determine if the function given below is continuous on each of the following intervals. If not, rewrite the interval so that the function is continuous in the interval. Okay, so the first one is -4 to 2. So -4 is here to 2. So I already see what? There's a jump here, right? So let's write that down. It's not continuous, so no jump at x equals what? -2, right? That's one thing we have to write, and then we have to write what? Rewrite the interval so the function is continuous in that interval. So we are going to write it as -4, comma, -2. That's where the jump is, right? And then from -2, it's not included, to 2, which is also not included. Okay, so the next interval they're asking us is from -2 to 2. It's over this open interval. It is actually continuous over the open interval. So, oh, no, only on, it's continuous only on the open interval, not closed interval, because there are holes, right? Now 2 to 4, that's good. 2 is open to 4, which is actually right. Right? Do you see that? It's 2, from 2 to 4, it is a smooth curve. And then from 4 to 8. So 4 to 8, I see what? There's a jump. So I'll change colors actually. No, jump at x equals what? 6, right? And let's write down the interval. It would be what? From 4 to 6, and they both not included because we have a vertical asymptote at 4, and 6 we have a hole, right? And then from 6 to 8, right? We're good. Okay, and the next one is from 6 to 8. Yes, it is. It is continuous over that closed interval. So the intermediate value theorem. If f is a function that is continuous over the closed interval a comma b, and y naught is any number between f of a and f of b, then there is at least one number c in that interval such that f of c is equal to y naught. So what are we trying to say here is, if you get a y value, right, or y naught, which we're saying here, is between your f of a and f of b, then there will be at least one number c which will also be in that interval, right? We're basically trying to show, I wrote it up here, need to show the y value you're looking for is in between f of a and f of b. The intermediate value theorem is an existence theorem. It tells us under what conditions c exists, but nothing about the actual value of c, right? A c exists only when it is between the two values, between f of a and f of b, right? Example 1. Given f of x, a rational function is given to us, show that f of x equals negative. This is basically your y value, that or for some value on this interval 0, comma 4. So we want to see if -3 is between f of 0 and f of 4. That's what we're checking. Okay. Before we even start checking that, I need to first check if this function is continuous over this interval. So look here. So the first thing always is to state continuity. Let's write that down. That is what you're going to be doing all the time when you're trying to prove the intermediate value theorem, because the definition itself says if f is a function that is continuous, so you must do that. So if I check, I can't really simplify anything. I know it's going to have what? A vertical asymptote at x equals 5, which is outside this interval, so it is continuous. So let's write that down. F of x is continuous on this interval. Must always mention that. Now you find out that value, whether it works or not. So first I need to find out, this is my second step basically. I'm going to find f of 0. So substitute 0 in for x. What do I get? 2 times 0 is 0 minus 3 is negative 3 over 0 minus 5 is negative 5. So I get 3/5. Similarly, I'm going to find f of 4, which would be 2 times 4 is 8 minus 3 is 5 over 4 minus 5 is negative 1, which gives me negative 5. So now look at this number 3. Does 3 falls between these two numbers, 3/5 and negative 5? Yes, it does. So what can I say? F of 4 or negative 3 does fall in between these two numbers, right? So we can say by intermediate value theorem, because it's asking us to show, so we have to conclude. But you can abbreviate that. Therefore, by intermediate value theorem, there exists a C on this interval 0, 4, which we were working with, such that f of c equals negative 3. You don't have to really memorize it. You're just writing it from up above here, breaking it down. Okay, so let's try number 2. It's again giving us a polynomial function. It's actually a quadratic function. Show that f of x equals 0. So we're checking, does this y value fall in between f of 1 and f of 2? If it does, then there does exist a c. If it does not, then we'll talk about it otherwise. So before we even do that, what do? We always check for continuity. So the first thing is to check for continuity. It is a polynomial function. It's actually a parabola, so it is continuous. So let's write that down. F of x is continuous on, they spell continuous wrong, I think I-N-U-O-U-S, on this interval 1, 2. Now the next thing I want to do is find my values of f of 1. What would be f of 1? Substitute 1 in here, so 3 minus 2 is 1 minus 5 is negative 4. Similarly, do f of 2, and I get f of 2 as 3. So now look at this number. Does 0 fall between these two? Yes, it does. So f of, which would be 1, or f of 1, or I can write it as 0 is greater than f of 1 is less than, that's how you write that it falls in that interval, right? So what can I say, which is a check? So therefore is 3 dots. If you were to write, therefore by intermediate value theorem, there exists a C on the interval. You have to mention the interval on 1, 2, such that f of c is equal to 0. So this is how you basically do these questions. So try your problem set and good luck.